Hello game makers, I'm David and this is the first episode in a mini-series where together I'll start little programming challenges and hopefully you'll be inspired to give it a try yourself and maybe take it further. I'm hoping on the screen you can see the finished product, and if you can, well that's a good thing and it means I managed to get something working. I'm recording this at the start so I don't know how it's going to go. For the first project I thought we could make a flocking simulator. A flocking simulator is a way of getting moving objects to cluster together in a really organic looking way. I've done it once before, so I'm already slightly cheating, but I remember you can get some really interesting emergent behaviour, great for birds in the background or spell particles. This might look like an intermediate level project, but actually I think together we'll be okay and it's simpler than it looks. Each episode will be a different coding exercise. There'll be a whole range of skill levels. Some projects might be smaller, some bigger, others not even be game related. In fact, most of the time they're not going to be game related. Also, it's not a guide on how to do this. It's definitely not going to be the best way to code this, whatever best even means, and it may not even be a good way of doing it, but it's about going on a journey together. The most important thing I want you to do is follow along and make your own better version. I don't want this to feel like a lecture, and I'm hoping at the end people of all skill levels will share their examples. So I want to encourage you, even if you just followed along with what I wrote verbatim, or if you're making your own flashier version, maybe you've used a similar thing in a previous game, share it with me.
Hey there, Future Dave here. I want you to share your version with me and the community. GameMaker has changed their Twitter handle to GameMaker Engine, and I think I'm going to try out Mastodon, so I'm Mr. Dave at mastodon.gamedev.place. So those are the best socials to use. Now, back to what I was going to say.
It'd be good to even upload this to the Opera GX platform so we can all have a play. I want this to be a learning experience for me as well, so do let me know if I've done anything wrong in the comments, or there's better ways of doing things. So, with all that said, let's have a look at what we want to make. I've pulled up the Wikipedia page for one type of flocking system called Boids. This works in both 2D and 3D. Today I'll be doing it in just 2D, but it's a good way that you can extend this project. What I like about this one is from 3 simple rules you get these complex behaviours manifesting. These 3 steps we want to follow are separation, alignment and cohesion. It does say it's already been used in some games like Half-Life, so maybe it's a tech you'll use in the future on one of your games. Let's look at each step and break it down. I'm not going to do them in the order shown, so let's look at alignment first. Here you can see the green Boid finds the other Boids around it. I'm going to call those its friends. It then tries to move towards the average angle that those friends have, so it's going to rotate to match their direction. Then in the cohesion step, we want to find the average position of all its friends and rotate to head towards that. Lastly, we need to make sure they don't get too close. This is called separation. So we want to avoid those ones near it. Great, let's actually get into creating the project. GameMaker has templates that allow you to start off with your own custom folder structure and some code, so I'm going to pick one of mine. And as always, the hardest thing with starting a project, giving it a really good name. Some of the observant amongst you may have realised that I've switched microphone. Cool, and with that done, I'm just going to clear up some of the initial things in my default template. Future Dave is going to narrate this, and that just gives me a little bit more control over narrating what's happening on the screen and what I'm thinking about. We're going to need objects to actually move around, so let's call it Object Flock. I actually regret calling it Object Flock later on. I think I should have called it Object Boid, but we are where we are. And we're going to need another object to spawn everything, so let's call that Object Spawner. All this is going to do is populate the screen with a few of these to get started with. A bit embarrassing here, you're going to see me trying to zoom in and I'm just fumbling around. Turns out the key is actually F8 and that will just enlarge the code to help you see it better. So it's rare I use a repeat statement, but this is a really good opportunity to use it here. So really simply, I'm just going to ask this code to repeat 20 times and each time spawn one of our flocking instance onto the screen. So at the very top, the very first thing, let's just get some stuff on the screen. So we want these to spawn at a random point on the screen. So I'm going to take a random number between 0 and then either the room width or the room height and use that as the location to spawn each one of these. because this is going to be quite a quick project, I don't care about the depth. I'm just going to put 0 there, and then we're going to spawn 20 of those OBJ flocks that we created earlier. And let's get started with this flocking object. We'll give it an image first so we can actually see it. You're going to have to excuse my very best attempt at art here. But the one important thing is that we know which direction it's travelling in, so I'm just going to make this an arrow. If you're looking to improve this project, please save my embarrassment and update this image file. Let's attach this work of art to the actual object so we can see something. And then give this a run to see what we've got. And whoopee! We've actually got 20 arrows displayed on the screen. That's exactly what we expected. Now, let's actually make them do something. I'm going to start off by just making them move forwards. And while they're at least moving, they're not moving towards the arrow, but that's fine, we can correct that later. We can make them all move in a random direction with direction equals irandom359. We'll give that a compile, and great stuff, they're all moving in different directions now. The arrow's still pointing in the wrong direction though, so let's fix that. If you're not familiar with GameMaker, I'm going to make a step event. Before, I was using the create event, which triggers once when an instance is first made. The step event triggers once a frame, so this code will run 60 times a second. And I'm just going to set its image angle to be its direction minus 90, and this will make sure the arrow always points towards the way it's heading. I'm just having a think about how I want to structure the code for each of these flocking objects. Writing these in comments is just a really good way to organise the code layout. Thinking back to the Wikipedia page, we have the 3 principles that we want to follow. I also know that I'm going to want to frequently know the friends or the other boys that are close to it. So we're going to want to find those so they're easily accessible. We have alignment, cohesion and separation. I'm going to write them out in a more natural descriptive way. So alignment is where it will try and slowly rotate to match its friends. Cohesion is where it will want to move towards the middle point of all its friends. And separation, where it will want to avoid being too close and bumping into its friends. Yes, I know, very sad. Now that I've got that sorted in my mind, I'm just going to work through each of those and break it down into its own region, just to keep the code nice and organised going forwards. Let's start by finding each of this Boyd's friends. These are going to be the other Boyds that are within a certain distance of it. I'm going to use 2 variables. One of them is going to be an array that's going to save a list of the instance IDs of each of these friends near it. So I'm going to call that one friends, and this one is just going to be friends count, and this is just going to be a number of friends that are near it. Now, I will notice later on that I actually called it friend count, but I'll correct that when I notice it. So how do we find which other flocking objects are close to it and which ones are not close to it? I'm going to use with obj flock to loop around every other flocking object. Now, rather weirdly, I want to check all flocking objects apart from the one currently looking for friends. So to do that, I'm going to make sure the ID of the object in the loop does not match the ID of the one running this block of code, and that will basically exclude itself. And then with every other Boyd, I'm going to do point distance, which is going to tell us how far away it is. When you see .other, that's actually looking at the variables for the one outside of the with. A really important part of this project is I want to play with the distances and speeds and how fast the Boyds can turn, etc. So I want to keep those values in a really accessible place so I can easily see them and change them. I'm going to start off with friends dists. So if 2 Boyds are within 50 pixels of each other, they'll be considered friends. So if any of the flocking objects get to this part of the code, then woohoo, we found a friend and need to put them in the array. As I said before, this array is going to keep the instance ID in it, so I can just refer to this friend really easily in the future. I'm also going to increase friend count by 1, and to do this I just use friend count ++. If you haven't seen that before, ++ just takes the current value and adds 1 to it. Let's actually test this. So at the moment all the code does is record what Boyds are within 50 pixels of each other, and each one keeps its own list of those friends. we're going to need a way to visualize this, and the easiest way I can think of is just to change the color of the arrow depending on if it has friends or not. So if you just excuse me, here we have some more classic Dave art, and then let's compile this to see what happens. Here we go. You can see those two in each other and have gone white, and those ones are changing between white and grey depending on who is near them. So that all works. They're still just floating off and going off the screen. They don't change direction yet, so that's something we need to fix, but we've already ticked off the finding friends step. And onto the match direction of friends step. We actually only want to change direction if we're close enough to at least one other Boyd. And again, just like the first one, I'm going to break this into a region so I can collapse it and keep everything neat and tidy. With a lovely descriptive comment here. Now, because we did all the counting of friends right at the start, I can easily say if friend count is greater than 0, run this code. And here my earlier typo will come to bite me. I've called one friends count and one friend count. I will notice in the future. So again, I'm just thinking about what I want to do here. We want to match the direction of all the Boyds around this one, but what does that actually mean? We're going to have to loop around every friend of this Boyd and find the average angle. Once we have this, we want to gradually rotate towards that common angle. And every other Boyd will be doing the same with its group of friends, and that will become the start of that chaotic but still organic behaviour that we're going to see. To find the average angle, I'm just going to add up the cumulative angles of each of its friends and then divide that by the number of its friends. And because we have this array with all of the instance IDs of its friends, I can use a for loop and just say friend.direction. So again, if you hadn't seen them before, plus equals is just going to add the number on the right onto the number on the left. And divide equals is just going to divide the number on the left with the number on the right. And here I noticed the variable is named wrong, so I'm just going to make that correction and overwrite it. But I kind of wish I'd have called it friends count. So far this just gives us the angle that we want to move in. We're not actually changing the angle of this current Boyd, so that's what we're going to have to do next. Eventually, we'll want this Boyd to slowly rotate to that angle. However, as a test for now, it's fine to just instantly snap each Boyd to this average angle. It's going to help us to test and will help us see what's actually happening under the hood. And once we know it's all working, we'll improve it to twist towards that direction. So my direction here, I just want it to be the same as running angle. So there was a small jump cut there, and there'll be plenty of others. However, I'd forgotten to change the image speed of the sprite to be 0. Without it, it very rapidly flickered between grey and white arrow images, and it just wasn't very pleasant to look at. I'm going to compile again, and you see, as expected, each of these arrows is actually rotating to match the angle of the ones around it. I can see they're not rotating perfectly, and it made me realise that the origin of those arrows must have been off, because when they rotate, it wasn't moving from the centre, and they're making very big jumps. So I've sorted that now. Right, now we've actually got them moving and rotating, let's get them to twist slowly. Rotating sounds like something that's going to be helpful throughout this project. For now, I'm just going to write the code inline. But eventually, it's a good candidate for this chunk to be placed in its own handy dandy function. To calculate which way I need to rotate, I'm going to use the built-in function angle difference. What this does is you provide two angles and it will return the difference between those two angles. I know that if this number returned is a positive number, I need to rotate clockwise, and if it's a negative number, I need to rotate counterclockwise. So, now we know which direction to turn, we're just going to either add or subtract 1 degree from my current direction, and that will make these Boyds rotate over time. Once we've done that, I'll give it a run to see what we have. So, I notice here that they're actually going away from each other. Not really what we wanted, but actually it's a good sign that things are working, and that seems like an easy fix. And yep, I've put the add and the subtract the wrong way around, so give me a moment and we can give that another try. This looks closer to what I was expecting. Things already seem to be grouping up quite nicely. Doesn't look very organic yet, but we're definitely getting there. There are two things I want to improve right now. First, things are just flying off the screen, and that's making it a real pain to debug. The other thing is, now we have them rotating, I want to be able to easily vary this. Rather than just hard coding that it's going to rotate 1 degree each frame, let's move that into the create event so I can easily set it and see it in the future. I'm going to keep it at 1 for now, but we're definitely going to have a play with that in just a bit. Okay, I think that's it for the alignment rule, so that's 1 of them down, just 2 more to go. We just have the separation and the cohesion to do. And it's going to be cohesion next. This is where we want to navigate towards the average position or the middle of the friend group, and that's always a lovely warm place to be. This one's going to be very similar to the previous alignment rule, so I'm going to start off with taking that chunk of code. I'm going to edit it so while the last one was using the direction of its friends, I'm going to alter this to use the X and Y of its friend's position. I need to keep 2 running counts now, 1 for the X and 1 for the Y. I could have technically put this in the previous loop, and it might have actually been a tiny bit more performant to do that. However, it was very important to me to keep this code clean and structure it so that each of these 3 rules had their own distinct block. I'm just going through swapping out all of the variables with the new ones needed. I almost forget to check the comments as well and keep them up to date, something I'm notorious for doing. I've just noticed that comment I just wrote says try and join ground rather than try and join group. It's a mistake there. There is something new needed that the first block didn't have. Previously we found their average angle, but now we're given a point in the world. We're going to have to find a way to know if that point in the world is on the left side of the void or on the right side. Luckily, GameMaker has another built-in function called point direction. Once I can find it. This takes 2 positions, an XY for each one, and will return the angle to get from the first to the second position. Once I have that, I know if I need to rotate clockwise or counterclockwise to get to that position. The first position is going to be where the void currently is, and the second position is going to be the position in the world that's the average of all its friends. So let's see what we've now got, and it doesn't look like a huge amount has changed. They're still following each other, but at least I know it hasn't crashed. So we've done 2 rules. Let's close that one. Before moving on to the final rule, it's getting too annoying that the voids just fly off of the screen and don't ever come back, so let's fix that now. I'm going to do that with just pointing rectangle. I'm going to keep it as basic as possible at the start. So let's first just find out if the voids are on the screen or off the screen. I'm going to give it the position of this void, and then if it's between 0, 0 and room width and room height, then it must be on the screen. If so, we can do something with it. I'm going to grab that same code we've used again and again to get the void to rotate. And all I'm going to do is I'm going to say if it's off the screen, then it needs to rotate back onto the screen. So I'm just going to point it to the very middle of the room. So now when I play this, what I expect to see is as one of the arrows leaves the screen, it's going to rotate while it's off the screen, and then a few seconds later it will come back. But that's not actually what I'm seeing here. I've obviously done something wrong, and I'm sure many of you must have noticed it when I did it, but I want to say if it's off the screen, I was saying if it's on the screen, then go to the middle of the room. So now, as you'll see, once one of the arrows leaves the screen, a few seconds later, it will come back onto the screen. So this is perfect, just what we were expecting. They're clumping up a bit too much, but we know the final rule should solve this. Now we've got something working, I'm going to play with the few constants we have. So just to help me run the simulation for a bit longer, I'm going to speed this up just to see what happens if I increase the forward speed of those flocking objects. It's all a little bit sparse now. The boids don't really stay together long enough to interact with the ones near each other. However, at least I know they're all looping back around once they leave the screen. And onto the last rule, separation. We've got them to clump up, probably a bit too much, so now we need them to spread out and become a bit more equidistant. In this one, we want to make sure the boids don't get too close to each other and maintain a good gap between them. We also need this gap to act almost like a high pressure wave, so that if there are too many in a group, they'll push each other out, and those ones push the others out, and so on and so on. It sounds very complex, but actually it's just a few simple steps. Up until now, other boids near each other have been called their friends. I don't know if I should have called these ones that are even closer their best friends, but I've called them their enemies, as they will need to repel each other. Duplicate the code at the top to distinguish between the boids at short range distance and the long range distant ones. Long range boids will be called friends and short range ones will be called enemies. I will also put this friends dist and enemy dist into the create event so we can edit them and see what happens when those values get changed. I'm really looking forward to seeing what happens when I start adjusting some of these ranges and how it affects how things moves. What happens if these numbers are really close to each other? What happens if they're really huge and almost cover the whole screen? What happens if I invert them so the enemy distance is the large one and the friends one is the smaller distance? We're going to find out. But for now, I'm just going to set them to be 80 pixels for friends and half that, so 40 pixels for enemies. And so, onto the main part of the separation rule. Again, I'm going to start off with the same foundation I used in the other rules. This one is going to be a little more different though. First off, we want this to run only if there is a boid near enough to be considered an enemy. If so, we want to find the best point that is the furthest away from all the others in this area. And when you think about it, this really is the same problem as finding the average position of its friends to be near to them, because the average point of its friends is the place where most of them are gathered. However, in this case, we want to move away from that place. So at this point, I'm just overwriting all the variables, so everything that used to say friends, well, I now want it to say enemies. I also noticed that one of my comments that I copied and pasted from earlier, that's still wrong, so I go back and correct it, and I go and correct the one that I pasted it from earlier. That's better, that's right now. Right, that all looks correct to me, so I'm going to give it a compile and let's see what happens. Well, they're still clumping up, and they're clumping up more than they were previously. It's not what I was expecting. Later on, I will realise, because I copied and pasted the code, it's telling its friends to be close and its enemies to be even closer. However, before I realise that, to help me debug, I'm going to make it so that the boids which have enemies should go red. At this point, I think it's a problem with each boid listing its enemies. However, I'm wrong about that. I assume this because things are grouping up and not repelling, so it's a good guess that it's down to having no enemies. But the real mistake is copying and pasting my code. In reality, I just haven't updated it so things rotate away from their enemies, and they're still rotating towards them. Either way, I've now made it so that the boids are grey when they have nothing near them, they go white when it only has friends, and red when it's got enemies. This will make things a little clearer to see going forward, so it's not all terrible. It's also at this point I realised that above typo, and after a little bit of stumbling with the keys, I actually get around to replacing friend count with friends count. So there's a little bit of relief there. I'm just checking all the very last places here, and then we'll compile and we should see them all going white and red or stain grey. And at least the colour changing part is working, but it looks like they're still following each other too much. So what I'm going to do here is, I think the problem is these two values are cancelling out each other, and what I do is I allow them to rotate even faster when it's got an enemy, but unbeknownst to me, this is actually compounding the problem and making it even worse. This is just the nature of debugging code. Once you know the problem, it seems obvious. And another thing to point out here is that I notice a little bit of wobbling back and forth when the boids are travelling in a straight line. That's something we've definitely got to fix. I'm actually going to fix the wobbling line first, because that seems like the easier things to fix, and I might notice the mistake while I'm making those changes. Also, this seems like a really good time to place all of those rotate blocks of code into a proper function, so I can put some more control over them. I've already used that copied and pasted code 4 times, so it's long overdue being refactored into a single script. I'm going to speed up this part because it's basically just me trying to be diligent with replacing the code. I start off with the same base I had before, where it uses angle difference to check if I need to be rotating clockwise or counterclockwise. I also add in the argument change speed that can be passed in. This will allow me to trigger this code and actually have different rules rotate at different speeds. And now I just have that code in one place and can call it with change direction to trigger it. I've actually just noticed that I replaced it on the 3 rules, but not on the part where the boids leave the screen and are told to rotate back. I will put this whole project on GitHub, and there'll be a link to it in the description below. So maybe if you fancy swapping out the code in the stay on screen region to use the change direction function, or just generally tidy up any of the code, you're more than welcome to make any of those edits. And here we can see that after this compile, I quickly just changed the number of flocking objects that were spawned and also the speed in which they can move forwards. So here, I'm just going to navigate to the place where it goes to avoid the enemies. And yep, I correct it so the angle it wants to navigate to is 180 degrees away from that angle, or in the other direction, away from those flocking objects that are too close. Another minor change, if anyone wanted to correct it, I updated the code and not the comment, so it still says move to match the angle when now it's actually doing the opposite. I'm now going to stop that annoying wiggling, and to do that I'm just going to say there has to be at least 3 degrees difference before it can start turning. However, that's really easy because with the change direction function I only need to update the one place. I'm going to make a little micro optimization here. Rather than checking angle difference twice, I'm going to do it once and save it to a variable because that's just quicker to reference. I never noticed that should be -3 on line 13 there. I wonder if that fix ever really worked. Oh well, I guess that's another thing just going to be updated once the project's on GitHub and some lovely helpful person can correct that for me. So things are starting to spread out a little now. We're starting to see that very classic diamond formation, and it doesn't take very long for them to gather into these groups that move very nicely together. Okay, so once they've grouped together, everything starts to get a little sparse, so let's make it so we can add some more when we click the mouse. It just seems right to do that in obj spawner, and rather than spawning it at a random location, I'm just going to get it to spawn at the XY of the mouse position. I won't need to worry about the direction or anything like that because that's still being randomised in the create event for the flocking object. Let's give that a try. I love these triangle shapes that we're seeing. Absolutely like when we see birds flying in the sky. And really, it's not a huge amount of code to start seeing this kind of behaviour. Let's spawn some more just to make sure they're all coming back and finding their groups. Great, well, This is really exciting that actually it all works, and very quickly each flocking object is finding a group, and just more join the group. They're each finding their position in the group and staying there as it moves around. And also the way the groups clash and interact with each other, it all seems very fluid and natural. I'm very happy with the movement here. The wobbling is still very apparent though, so even though I tried to fix it, I mistakenly put 3 rather than -3, so disappointing I didn't catch that earlier. This is kind of like the basics of what I wanted to get working. Now we've got this far, we're absolutely going to try playing with some different ideas I've been having. So what we're going to do first is give each Boyd a random forward speed and have a think about what's going to happen if some are moving faster than others. Do you think it will impact how they stay in groups? Maybe they'll never find groups. Maybe some groups will stay on a particular side of the screen. Maybe we'll get balls of them grouping up with each layer having different speeds. Now, it is hard to see what is happening, so I'll add some more in. They're semi-clumping up together, but they're definitely not as clumped up as they were when they all had the same speed. Just to make it more visually obvious which one's moving faster and which ones are moving slower, I'm just going to draw a coloured circle on top of them that displays their current speed. I will make it so the fastest moving ones are green and the slowest moving ones are displayed red, and everything in between gets a gradient between the two. To do that, I'm just going to use make colour HSV and input some dynamic values for the hue portion. First off, let's just make them all red, just to make sure it's working. Now, it should be some fairly simple code here, but I stumbled quite a bit trying to work out the hue, saturation, value colour of it. I want to multiply the hue by the speed. However, the Dave that's typing this originally has forgotten the speed actually goes between 1 and 5 rather than 0 to 1. So it's actually going to go right over the maximum 255 allowed for the hue portion. We've got them being coloured, however the green ones are going the slowest. Also, we need to include the minimum speed into the calculation. I get most of it working, however the colours are not exactly what I want. I'm still going to quickly run it though so we can have a preview of what it's going to look like. While there's far less clumping, it's pretty obvious that incredibly quickly Boyds find other Boyds travelling at a similar speed. Now, I embarrassed myself by taking far too long trying to work out how to flip the colours and get the min speed included, so I'm just going to speed it all up and pretend that never happened. So, fast forward of me making far too many silly mistakes. The final solution I came up with was just using a map script I had in my back pocket that I had in the project files loaded from this framework. It works a little like the built-in lerp function, but rather than going between 0 and 1, you can have your own custom range to go between. So let's give it a compile, and here we have it. So the coloured dot on each one represents what speed it's moving at. The interesting thing is you can see them clumping together by speed. It seems obvious now that you get bands of purple ones together, bands of the blue, red, green ones all together. This is happening because the fast ones are outpacing the group and the slow ones just can't keep up with the main body of the group, so they stick with ones of similar speed. The thing that is so impressive is how fast this is happening. Another thing I notice is the whole group of them seems to orbit around the whole screen in a counterclockwise formation. I wonder if this is a rounding error on my end that makes things generally more likely to turn left, or if actually a population of this density will tend to have enough Boyds in it that they can form a circle and all follow the one in front in a big chain, and that always leads to have this kind of end result. Now that we've had a play with the speed they move forwards at, let's see what happens when we make the group sizes bigger or smaller. First, I'm going to need to put in some more debug commands so I can internally see what is happening. Let's start by drawing the radius of things the Boyd will consider a friend or enemies on the screen. I don't want to display all of them, so I will only draw this ring if the flocking object is close enough to my mouse. I'm going to use a white ring for everything in the friends group, and in the future I'll add a red ring for the enemies. Now I've added that, let's just give it a run to make sure it is actually working. So just as we expected, here's the little ring. And actually they haven't been able to see very far around them. Because remember, they've only been interacting with other boids that are in that area, so it's a very limited group. Let's make that number much larger now and see if it has an impact. My opinion on this is things are just in too many groups now, so a lot of the cohesion they had before is gone and it's a lot more tricky to see the organisation. I'm going to add in a few more to see if that helps. Maybe it looks like we get these longer conga lines of them moving around. Maybe it looks a little bit more like flowing water. But generally it's just one big cluster where the fast ones leave from the front and flow back around and enter the pack again. Maybe if we zoomed out and did this on a huge scale, these bigger radiuses would look more impressive. I'll dial that down to something a bit more reasonable for this screen size. One thing that I never do that I'm thinking about now is what would happen if each boid used a random range for each of these radiuses, like we did with the speeds. My first thought is that this would make things far more messy, but as this simulation keeps demonstrating, often those chaotic changes on a grand scale present some interesting visual effects. Now that we know we can change the size that the boids can see around itself, let's add in some debug commands so I can change them live. I'm just going to use the keyboard arrow keys for this, up to make the range bigger and down to make it smaller. I'm going to print it out in the output console with show debug message, just so I can check what values I'm using, even though it's going to get real spammy real quick. It's not going to be very easy to read, but also it's going to allow you just to see when I'm changing it up and down by looking at the bottom left of the screen. So here you can see it says 100, and as I change it goes 102, 4, 6, 8. There we go. It's probably not enough though. I need to make it change more in each step. It's taken me too long having to hammer my keyboard. I'm just going to edit this, so rather than going up in increments of 2, it's going to go up in increments of 10. That way I don't have to mash my keyboard to get big changes in values. And while I'm here, let's make it so with left and right arrow keys I can do the same thing, but use this to edit the enemy distance range instead. I often talk to other developers about putting in good debugging systems in from the start. I kind of wish at this point I also put in a proper display on the screen so we could see some of those raw values live. I think it would have made it easier to see when I changed it and what the internal values was, and just generally make it easier to read. Keeping with our convention, I've made it so there's a red ring for the enemy range and the white ring is for the friend range. The boids are moving a little too fast for me to keep my mouse over them, so I'm just going to pull down the maximum speed a little. I keep the minimum the same though. One thing that shocked me is if the view range for the friends was small, the enemy range was comparably tiny. Now, I know they're grouping up and quite often in those ranges for each other, but it still just seemed very small. So I've been using the keyboard to change these values, and the first thing I wanted to try was, what happens if these values are very similar to each other? I've made it so the enemy radius is massive and only a little bit smaller than the friend radius. Well, things now tend to spread out more, it all comes a bit less dense. I've now also increased the friend radius, and seems like they have just captured everything onto the screen into one swarm, and because the enemy distance is much bigger now, they are just far more dispersed. They all reach the edge of the screen here and like one big pressure wave, they just kind of like bounce back as one big glob. So the next thing we can change is their rotation speed. They rotate very fast at the moment, so let's bring that down and see if they can still stay in their formations. Right, well, they're all just scattered off the screen. One of the problems I didn't foresee is that that number is used to say how fast they can rotate back onto the screen. While it's certainly less pronounced now, you can still see some small groupings with clusters of 3 or maybe 4 very similar colours. Again, it's worth remembering how simple this system is. There isn't massive amounts of data being passed between these boids. They just check the position and directions of the ones they can see. They're not in collusion with these huge plans about where they will go and what direction they want to face, but we still get in these massive world-based movements and groupings very naturally. So let's now give each of the flocking objects a slight variation in what their range for friends and enemies is, and think about how that's going to change the outcome of the simulation. It's now quite lumpy, it's hard to see them grouping together, though I do wonder if I kept this running for a longer amount of time if things would become far more formulaic. However, from first glance, it does look like they're not acting as one anymore. I assume this is because some boids that consider another a friend might be considered an enemy by that one. Yeah, it's definitely far more sporadic now. So we've had our fun with that, let's try something else. I've put it back to them all using the same distance, and now let's increase the range of speeds so that some can have wild forwards momentum. Well, actually no, that's too massive, that's far too fast. Let's dial that in a little and also allow them to change direction far more rapidly. Very quickly you can see these chains of them forming together, swooping around up and down. I love the way that blue one came down and off the screen, and the way they're ordering themselves by colour into these long trains. It's like they've sorted themselves for us. Now, I might have added a few too many here. They've sort of clumped together and they're in a death spiral, all chasing each other's tail. But it does make me wonder, what if these flocking objects had more room to move and form up? So I'm going to increase the room size. I guess I could have got the same effect by halving all the speeds and the view distances, but I didn't think about that at the time. I just need to make this change in 2 places, and then we can see how it impacts the boids being given more area to form up before being pushed back onto the screen. Yeah, this is what I'm talking about. I think it'll make a really great screensaver. I love this. Loads of interesting groupings, from the slow ones bobbing along and then the fast ones whizzing into things and impacting the paths of the one around it. There is an awful lot of emergent behaviour being seen, and in my mind I definitely see it like little schools of fish wandering around and looking for food. This is just one method for doing flocking, but there are plenty of others out there. One thing I liked about this particular method, called boids, is how each flocking object treated itself as an individual and doesn't process anything outside of what it can see. They're also autonomous, and there's no main controller telling them what to do. Right, I just reduced the speed a little so we're back to a little more natural system. So a really important part of this video to me is encouraging you to take this further. There are plenty of things you can add, like trails going behind each of these boids. Maybe you want to add different types moving around, some that are pursuing each other and others that are avoiding the other boids. Maybe some that are chasing food or another resource. How would you add terrain? Can you add an island or mountains that should be avoided? Maybe you can add better debug control so you can edit it with the mouse. Or code optimization. What happens if you put 500 on the screen? Or can you get 1,000 or 10,000 on the screen? Or maybe you've already used flocking in one of your projects and I want you to share it with the group. I'll put this example on GitHub, spelling mistakes and all, and hopefully this brings up the skill level of all those that get involved, including myself. There's also plenty of reasons why you might consider using this type of flocking system in one of your future projects. I can see it being used for bullet hell games to move enemies or bullets around. I can imagine it being used for spells and particle effects that you want to interact and flow in a very natural way. It might just be used for little butterflies or birds in the background of the game, because I hope I've shown it's super lightweight and very, very flexible. So I think that's enough playing around, and I'd like to see what you do and where you take this. I'm going to put this project on GitHub, so there'll be a link to that in the description below. There's already a whole bunch of enhancements that you can just start with. That add better graphics, change graphics, make it look better. That's a really easy place to start. I'm sure there's a whole bunch of spelling mistakes that I made that can be corrected. I think some of my comments that I copied and pasted from other areas were never updated. Those were wrong. Please fix them for me. I've got to put the change directions script when the Boyds leave the room, so it's still just using the standard change angle code. When I was comparing the angle differences, I left one value as 3, and I think it should have been -3. Go and fix that for me. And I'm sure there's a whole bunch of other things that you saw, I made a mistake, that you can correct. Also, if you're making your own version, I want to see what you do, and what changes you've made. Remember to share it.
Hey, it's Dave from the future again. On the screen, I've put the new socials to use. And if you can use the hashtag GMPAL, which stands for GameMaker Program Along, that will help us all find it. Okay, back to the video.
If you already have this in one of your own projects, share the game. We want to see how it's been used. Thank you very much for watching. I'm David Strachan. I hope you enjoyed the rest of your day.